Hello everyone, welcome to Learn Spring Boot with Bingyang. In this video, let's upgrade our application, Hogwarts Artifacts Online, to the latest Spring Boot version. Actually, we already did that in a previous video, but it's such an important subject that it deserves its own dedicated discussion. So here we go. A website that I highly recommend for every Spring Boot developer and enthusiast is calendar.spring.io. It provides comprehensive scheduling and event information related to the Spring ecosystem, not just Spring Boot. This calendar serves as an official central hub for staying updated with the latest Spring-related events. As you can see, Spring Boot 3.2.0 was released on November 23rd, 2023. And 3.2.1 will be available on December 21st, 2023. So why does upgrading matter? Keeping your applications up to date with the latest Spring Boot versions is crucial for leveraging new features, ensuring security, and maintaining optimal performance. However, upgrading Spring Boot is not just simply changing the version number in the pom.xml file. It can be a significant undertaking, especially considering the complexity of your application and the differences between the versions. It is a task that requires thorough preparation and careful implementation. Let's go back to the slides. In this video, I will guide you through the best practices for a smooth and effective upgrade process. Even though I'm teaching Spring Boot, most of the best practices here also apply to other frameworks and technologies. So when upgrading a software package, you should review release notes and migration guidelines, backup and use version control, update dependencies, update configuration properties, remove deprecated classes, methods, constructors, test thoroughly after upgrading, upgrade incrementally, start with a test environment, monitor logs and performance after deploying the upgraded application, use Spring Boot Actuator to check the health of the application after an upgrade, seek community help, and document the changes. All those are best practices for upgrading a Spring Boot application. So let's dive in. But first, let's briefly talk about semantic versioning. As of the date of this recording, the most recent version of Spring Boot is 3.2.0. If you're watching this video in the future, the version may have advanced. Despite that, the procedures and best practices discussed here remain relevant, so keep watching. What is this 3.2.0? We know it represents a Spring Boot version, but what does this mean? Software has a life cycle. It will evolve over time. For example, we may fix bugs, make modifications, introduce new features, and so on. For software package developers, in this case, people who created Spring Boot, and software package consumers, in this case, people who are using Spring Boot, like us, keeping track of versions of a software product has always been a problem. There are many ways to keep track of updates and releases of a software product. One of the most effective ways is called semantic versioning. Semantic versioning is a three-component number in the format of major version, minor version, patch version. What do those numbers mean? Let's start with the patch version number. Software package developers usually increment patch version number after fixing some bugs. This kind of change is not meant to alter the software's existing functionality. So if the software package consumer is currently using version 3.2.0, upgrading to 3.2.1 will have no problem at all. In other words, it will not break the package consumer's project. Next is the minor version number. This number is incremented when developers add new features to the software, that are still compatible with former versions. For example, version 3.2.0 will still be compatible with 3.3.0. With minor version upgrades, consumers would definitely see changes to the software's functionality and features, but the change is less risky for them because consumers' current project will not break. So minor upgrade and patch upgrade are less risky for consumers. Consumers don't have to do anything in their own project that depends on this package. Now let's talk about a major version upgrade. When developers make significant changes, for example, change software's APIs, drop some features, changing minimum environment requirements, they will increment the major version number. This means that the changes are extreme to the point that they render the software incompatible with older versions. In other words, no longer backward compatible. At this point, the software package has evolved drastically. For example, if a project is currently using version 3.2.0, when upgrading to 4.0.0, this will break the consumer's project. So be very careful in this situation. However, in practice, this ideal is not always achieved. Software package developers might inadvertently introduce breaking changes in what are intended to be patch or minor upgrades. I will show you an example later on. Next, let's go to IntelliJ and upgrade our Spring Boot application to 3.2.0. This is the list of best practices you just saw. First, let's follow best practice number 2, which is to back up our project and use version control. So let's create a branch for this upgrade. Git branch, let's call this Spring Boot 3.2 upgrade. Git switch. Okay. As I mentioned at the beginning of this video, I have already upgraded the application to 3.2.0 in a previous video. Recall that we were using Spring Boot 3.0.3 when we first created this project. Now, as you can see, we're using version 3.2.0. So make sure you change this version to 3.2.0. And let me write a comment here. And make sure you load Maven changes. Next, let's go through each best practice in this list. First, let's review the release notes. Before starting the upgrade or migration, you need to carefully review the release notes and migration guidelines for the target version of Spring Boot. In our case, Spring Boot 3.2. This document provides critical information about new features, deprecations, and potential break-in changes. This document is pretty lengthy, but I want to direct our attention to this section. Nested jar support. In the latest Spring Boot 3.2.0, the launcher classes have new binary names or fully qualified names. In particular, the org Spring Framework boot loader jar launcher class has a new binary name. Org Spring Framework boot loader launch jar launcher. It has been relocated to a new package. So pay attention to the launch in the path. This change is crucial for developers using Docker to containerize their Spring Boot applications, particularly if they have configured jar launcher as the entry point in their Docker file. So let's go there. Take a look at line 13. As you can see, I've already changed the name of this jar launcher. And let me put a comment here. The jar launcher class has been relocated to a new package since Spring Boot 3.2.0. Neglecting to update the path to the new location of the jar launcher could lead to a class not found exception like this. Okay, since we went from 3.0.3 directly to 3.2.0, I also want to point out two important new features introduced in 3.1.0, and let's take a look. Here we're looking at the release notes of Spring Boot 3.1. Spring Boot 3.1 introduced support for Docker Compose in Spring Boot. By adding this dependency, Spring Boot Docker Compose in the pom.xml file, we get the support for Docker Compose in Spring Boot. So basically what we need to do is to declare the services in a Docker Compose configuration file, for example, docker-compose.yml. And when we start our Spring Boot application, all the services declared in the configuration file will be started up automatically. Of course, behind the scenes, Spring Boot is issuing the command docker compose up. And when our Spring Boot application stops, all the services declared in the configuration file will then be shut down using docker compose down. So as developers, we no longer need to manually type docker compose up and docker compose down. The services declared in the docker compose YAML file start when our Spring Boot application starts, and they stop when our Spring Boot application stops. How convenient. The next important feature I want to point out is test containers. Spring Boot 3.1 introduced improved support for test containers in Spring Boot. So what is test containers? Test containers is an open source framework for providing throwaway, lightweight instances of databases, message brokers, web browsers, or just about anything that can run in a Docker container. Test containers is often used in integration tests. The purpose of test containers is to make developers' life easier. And I do plan to make a video on that, so we can refactor our integration tests. Stay tuned. Okay, that's for best practice number 1. Best practice number 2 is backup and use version control. We just did that. Make sure your code is backed up and under version control. This allows you to track changes and quickly revert back if needed. Let's move on to best practice number 3, update dependencies. Let's go to IntelliJ. When you upgrade your Spring Boot application to a new version, you must ensure that all your project's dependencies are compatible with the new version of Spring Boot. Thanks to Spring Boot's dependency management, this is made much easier. Let's click into Spring Boot Starter Parent, and then click into Spring Boot Dependencies. Let me collapse this. Recall that this dependency management element in this Spring Boot dependencies.pom file defines a very long list of dependencies supported by Spring Boot. And the versions of those dependencies are defined here in the properties element. It turns out that each release of Spring Boot provides a curated list of dependencies that it supports. So when upgrading our Spring Boot application, in most cases, we don't have to worry about upgrading the versions of the dependencies, since it has been taken care of by Spring Boot. However, in our case, there is one exception. So let me close this. So let me scroll down. Recall that our Spring Boot application depends on this Spring Cloud Azure. Unfortunately, at this moment, Spring Cloud Azure is not included in that curated list of dependencies that Spring Boot has. So we'll have to make sure that this dependency is compatible with Spring Boot 3.2. And its version is defined right here in the properties element. Here. So this version was 5.6.0, and we need to bump it up to 5.7.0. As you can see, I already did it. If you're still using the old version, Spring Cloud Azure's compatibility verifier will complain. So let me put a comment here. If you are curious about the logic of the Azure compatibility verifier, you can take a look at its source code. So let me show you really quickly. Just a search Azure compatibility, and let's go to classes. It's right here. Azure compatibility verifier properties. As you can see, Spring Cloud Azure 5.7.0 introduced support for Spring Boot 3.2.x. But in version 5.6.0, it only supported Spring Boot 3.0 and 3.1. Okay. Next, let's move on to best practice number 4. Update configuration properties in application.yml and application-**.yml. This is something we didn't do before, so let's go for it. Every time Spring Boot releases a new version, it's common to encounter changes in properties. Some properties may be renamed, deprecated, no longer be supported, or there could be brand new additions. As you can see here, on line 5 in application.yml file, throw exception if no handler found is deprecated and will be removed in a future release. Then how do we know these changes? To keep track of these changes, Spring offers detailed configuration changelogs with each version release. Let's take a look. This configuration changelog documents the configuration property changes between Spring Boot version 3.1.6 and 3.2.0. 3.1.6, as of the date of this recording, is the most recent version in 3.1. As you can see here, those properties become deprecated. Those are newly added in 3.2.0. And those are removed. While this changelog is comprehensive and informative, it is also lengthy, with many properties irrelevant to our needs. The key question here is, how will these changes impact our Hogwarts Artifacts Online project, right? That's what we care most. So here, I will show you 2 approaches to spot those property changes in our project. The first approach is to use a support system provided by Spring called Spring Boot Properties Migrator. It simplifies the process by delivering tailored information relevant to your specific Spring Boot setup, making the migration to newer versions more straightforward. The second approach is to use IntelliJ's Inspect Code feature, which is the one I prefer. Let's go over them one by one. Let's go back to IntelliJ. Let's first add the Spring Boot Properties Migrator dependency in our project. Okay. Also, let's add a scope. Runtime. Okay, don't forget to load Maven changes. All right, once added as a dependency to our project, this will analyze our application's environment and print diagnostics at startup. So let's start our application. Okay. Great. The Spring Boot Properties Migrator finds problems. It says the use of configuration keys that are no longer supported was found in the environment. And it points to me that on line 5 in application.yml, this spring.mvc.throw_exception if no handler found is no longer supported. It also gives the reason. Dispatcher servlet property is deprecated for removal and should no longer need to be configured. So that's easy. Simply just remove it. In a different scenario, for properties that have known replacement, this Spring Boot properties migrator will tell you the replacement. So it's very convenient. Okay, so let me close this. So if you're using Spring Boot properties migrator, here is a small warning. This dependency is meant to be used only during the upgrades in development environments. Once we use it to identify the properties to be updated or removed and then correct them, we can remove the dependency from our dependencies. So remember, don't keep this dependency in production. For your reference, I will keep it here, but I comment it out. Okay, so let me turn it off. Then let me show you the second approach to find deprecated configuration properties. And as I said, this is the one that I prefer. IntelliJ offers a powerful feature that can find deprecated properties or methods or classes or constructors in your code base. So it's very powerful. So let's go to the menu bar and select code. From the drop-down, select inspect code. A dialog box will appear where you can specify the scope of the inspection. So here I will choose the whole project, but change this as you see fit. Once you select the scope, click Analyze. Okay, IntelliJ is doing the work, scanning the entire project and finding problems. As you can see, IntelliJ already found 3 errors. Okay, I think it's complete. So first, let me collapse this. And let's look at Spring first. And there's one warning. So here, IntelliJ says, invalid YAML configuration. Dispatcher servlet property is deprecated for removal and should no longer need to be configured. So this is consistent with Spring Boot properties migrator. All right, so let's go ahead and remove this property. Okay, that's done. This configuration property is no longer needed because the code of dispatcher servlet is refactored. So let's take a look. So let's try to find dispatcher servlet. It's right here. And let me search this property. It's called throw exception right here on line 308. As you can see, by default, throw exception if no handler found is true. So there's no need to explicitly set it to true in my application.yml because by default it is true. But this was not the case in the previous version. In the previous version, the default value of this property is false. That's why we have to set it to true in the application.yml file. All right, so let me close this and close this and keep reading the report from IntelliJ inspect code. Let me collapse this and expand here. So let's move on to upgrading best practice number 5. Replace, remove deprecated classes, methods, and constructors. So in this case, IntelliJ finds 3 APIs marked for removal. In other words, deprecation. All 3 problems are in security configuration class. So let's take a look. Okay, so here is the first problem. And let me move the cursor over. And usually IntelliJ might suggest alternatives or quick fixes for some deprecated methods. So this method is deprecated since version 6.1 and marked for removal. Oh, by the way, here 6.1 refers to the version of Spring Security. So let's click inside. Okay. And here it says I should either use frame options and pass a customizer to it, or frame options customizer dot with defaults to stick with defaults. So let's go back here and we're going to use the defaults. Customizer dot with defaults. Okay, now you're happy. All right, let's move on. The second problem is GWT. Okay, it's right here. And I assume that is the same problem. And this method is also deprecated. So let me click into it. So same solution, I should use customizer dot with defaults. So let's go back here. Okay, now you're happy. Now the third arrow here is and. It's right here. So this is also deprecated. So let's go inside. So here it says deprecated for removal in Spring Security 7.0. Use the Lambda-based configuration instead. Okay, so that means we can simply just remove it. And let me properly format this. Okay, now this looks much better. So OAuth to resource server .gwt, then .authentication entry point, then .access denied handler. So this format is more consistent. All right. So let's keep going. So this is a very useful feature. So this is under Java code maturity, usage of API marked for removal. Okay. The next important one is this code style issues. So let's take a look here. All right, so field may be final. So let's correct those. Those are not necessarily wrong, but it's just a not good coding style. So let me change this to final. Okay. And here, yeah, same thing here. Let's make it final. And in user service, the password encoder should also be marked as final. And just for information, using the final keyword to modify a field in Java is considered good practice. It makes this field immutable, and immutability is important. First, it prevents accidental modification, and second, immutability simplifies programming in multi-thread programming. In some JVM implementations, fields marked with final can also improve the program performance. Just to let you know. All right, one more thing. So this @deprecated annotation. In my opinion, deprecated code should be refactored as soon as possible because they will be removed in a future release. For example, Spring Boot basically follows this simple rule. An API that is marked deprecated will be removed 2 minor versions later. For example, if an API is marked at deprecated since 3.2.0, this API would be subject for removal in 3.4.0. So make sure you find all the deprecated code and refactor them accordingly. All right. So let's run the inspect code again. Okay, now the errors are gone. But we still have a bunch of warnings, weak warnings, grammar errors, typos, and so on. So here is a small homework for you. Use inspect code feature to check the quality of your code. And go over the errors, warnings, weak warnings, and even grammar errors and typos and fix them. Since we refactored our code, next, let's run local tests. So this is the best practice number 6, test thoroughly after upgrading. Okay, all tests passed. Next, let me commit and push the changes to GitHub, and also deploy the application to production. Then we'll come back to the slides and talk about other best practices. Upgrade to Spring Boot 3.2.0. Git push. Okay. Then let's go to GitHub. Okay, so let's compare and pull request. So here, as you can see, we changed Dockerfile, pom.xml. We added keyword final to the 3 private fields. We also replaced the deprecated methods, and we removed one deprecated property. Then let's create pull request. And this will trigger a GitHub action workflow.
2,000 years later.
Okay, then let's go to pull requests and merge pull request. Confirm merge.
"2,000 years later."
All right, it's deployed. Let's go back to IntelliJ and synchronize the local main branch. Git switch to main, and then git pull. Okay. Now our local main branch is synchronized with the remote main branch on GitHub. Next, let's go to the slides and talk about other best practices for upgrading a Spring Boot application. Okay, let's move on. Best practice number 7, upgrade incrementally. If you are several versions behind, consider upgrading incrementally through each major minor release, rather than jumping directly to the latest version. For example, if you are using Spring Boot 2.5.1 and want to upgrade or migrate to Spring Boot 3.2.0, make sure to first upgrade to the latest available Spring Boot 2 version, like 2.7.x. Once that is okay, from there, upgrade to Spring Boot 3.0.0. If that's okay, then upgrade to 3.2.0. This progressive upgrade approach can help identify and resolve issues more methodically. Recall the semantic versioning, where a patch version upgrade will not break the consumer's code. Here is a problem I encountered recently. Offline, when I upgraded Hogwarts Artifacts Online from Spring Boot 3.0.3 to 3.0.9, my security configuration code broke. Here is the error message. It says, this method cannot decide whether these patterns are Spring MVC patterns or not. If this endpoint is a Spring MVC endpoint, please use MVC request matcher. Otherwise, please use ANT path request matcher. Behind the scenes, this Spring Boot upgrade bumped Spring Security 6.0.4 up to Spring Security 6.0.5. So apparently, Spring Security 6.0.5 introduced this breaking change, even though this is just a patch upgrade. It turns out that this problem is due to some false positives with the validation put in place in response to CVE 2023-34035. CVE stands for Common Vulnerabilities and Exposures. The Spring Security team fixed the problem I encountered in Spring Security 6.2.0, which was released together with Spring Boot 3.2.0. So now we're good. I just want to share this story in case you encounter this problem. I included a link to this GitHub issue in the description of this video. Take a look if you're interested. Best practice number 8. Start with a test environment. Ensure that you perform the upgrade in a development or test environment first. Do not start the migration directly in a production environment. In our case, we have set up a staging environment on Azure, so we can use that for testing purposes. But do feel free to create a dedicated environment for testing. Best practice number 9. Monitor logs and performance. After deploying the upgraded application, monitor logs for any unexpected errors or warnings and keep an eye on performance metrics to ensure there are no regressions. Best practice number 10. Use Spring Boot Actuator to check the health of the application after an upgrade. Spring Boot Actuator can help you monitor and manage your Spring Boot application. It is particularly useful for checking the health of your application after an upgrade. So let's take a look. As you can see, after upgrading to Spring Boot 3.2.0, our application is still healthy. The status is up. Best practice number 11. Seek community help. If you encounter issues, don't hesitate to seek help from the Spring community, either through forums or Q&A sites. You can also submit issues to Spring Boot's GitHub repository to report a bug you found during upgrade. Just like the story on Spring Security I shared with you a moment ago. Last but not least, best practice number 12. Document the changes. Remember to update your project's documentation to reflect the changes. Also, provide necessary training or updates to your team regarding new features or changes in the upgraded version. Okay, that's it, we're done. In the future, I will periodically upgrade my Hogwarts Artifacts Online to the latest Spring Boot version. That's it. Hopefully, you now know the best practices for upgrading a Spring Boot application. As I said before, these best practices also apply to other frameworks and technologies. See you in the next video.